Hi, it's Pekka. In this presentation, I go through the most important enhancements and other changes in Robot Framework 7.0 that was released in January 2024. I'll start by going through the enhancements that normal Robot Framework users can utilize when creating test or tasks. And after that, I'll go through the enhancements more targeted for developers creating extensions such as libraries and listeners. Along the way, I'll also cover some of the backwards incompatible changes as well as some deprecations. I'll go all these changes through using examples that I create as part of this presentation. If you want to see the examples afterwards or want to run them on your own system, you can find them from the GitHub repository shown here on this slide. The repository contains also some more information about the release, such as links to the release notes, where you can find information about also other features in the release that we don't have time to cover in this presentation. Okay then, let's get started with going through the enhancements. The most important enhancements for normal Robot Framework users that they use directly when creating tests or tasks is the new var syntax for creating local and also local variables and also variables and other scopes. Let's see how it works. So first, of course, I need some kind of a test case here. And then directly inside the test, I can use the new var syntax. I'm using the excellent robot code editor here on VS Code, and it also already supports this new enhancement in Robot Framework 7. So I can use the var syntax here. Then I need to give a name of the variable like this, and then value of the variable like this. So what I did is that I created here a variable called name with the value Robot Framework. But not very interesting yet. Let's see some other examples. If I want to create a variable that has somewhat longer name, I can use the exact same syntax here. Name, I'll just use longer this time. And then when I create the value, instead of continuing this line forever, I can continue it from the next line using the command 3-dot notation here. I'll just continue like this. This value will, although it's now on multiple lines, will actually be concatenated together so that the parts are joined with spaces. So it will be just a single one-line string. If I want to use some other separator, for example, if I want to use a new line as a separator to create a multi-line string, that's easy as well. I use obviously the same syntax as earlier. Then I use another name. Let's use multi-line here. And then let's just use first line here. Second line. Last line. So this obviously is still just a single line string. No difference compared to the earlier one. But if I use the separator configurator parameter here at the end, like this, now it is going to be a multi-line string. The reason it's going to be a multi-line string is to use this \n escape sequence. If I would use something else, that would be used as the separator. This syntax supports also creating lists in not only this kind of scalar variables, and that's just requires using the @ sign here instead of the $sign when creating the variable name. So let's use list and then first item, second item. We can also again here continue the next line if you want, if you have more items. Just last item here. Unlike with the earlier examples, these parts aren't joined together with spaces. Instead, we get the list with 3 items. Now that we have these variables here defined, let's see how they look like when we log them and they got the values that we expect. So we can use log keyword or possibly log many since we have multiple values we want to log. So let's use first that name. As you can see, the editor notices we have this variable. We have variable longer, we had variable multi-line, and also we have the variable list. So all those four we are going to log. Well, the last one we cannot see. Maybe we use the 3-dot notation here as well to get it seen here on the same editor window. Now we can run this test case exactly as earlier, repeat the robot command and then path that file like this. Test passes kind of means that the new syntax was recognized by the framework, and we can see in the log file how it looks like. First of all, we have the var syntax here 4 times with different kind of values, and then we can see when you look at the what was logged that the values are as expected. Now that we are looking at the log file, we can also look at some other enhancements here, most in the dark mode. So this just looks exactly as earlier. I'm using the light mode that was picked from my system settings, but if I want to switch to the dark mode, there's a toggle here on the corner, and I can click that, and now I'm using the light mode. That also works. Sorry, I've used the dark mode. There's also the same thing in the report now. We can see that it's using the dark mode. I can switch back to light mode here and back to dark mode and so on. So let's go now back in the log file. I think I'll switch to light mode back. I think it works a bit better in this presentation here. So yeah, that's how the var syntax works when creating variables in the same scope, like a local variables. I can use it here in the test case. I could use it inside keywords and of course tasks as well. In this usage, this new syntax basically can be used instead of the set variable keyword that can be used to return a value that can be assigned to a variable, instead of a concatenate keyword that supports this kind of creating longer variables, also multi-line variables, and it can be used also instead of a create list or create dictionary that allow creating dictionaries and lists. This syntax can also be used instead of keyword set suite variables and set global variable and set test variable. Those keywords allow creating variables that are available also in other scopes, not only in the local scope where the keywords is used. And with that works also with this var syntax as well. So let's see how it goes. I use the var syntax again. I use the Scala variable. Let's use, for example, suite level. I use capital letters here with the variable names because that's a common convention with the kind of with value variables that are available in other scopes than the local scope. The value is here. Well, just use value. And the thing that makes it actually available on suite level is this scope configuration parameter, and give a value suite. Other options instead of this suite is a test to create a variable that is available everywhere within the test. Global, that makes it also available in subsequent test suites, and then local, which is also the default. So this value is obviously visible here, so I can use log to log it like this. And also, it's now available in the next test case. So I can use var continued. Let's create a new test case here just for demonstration's sake. And I'm gonna also here log the suite level variable. See how it goes. It succeeds, so the variable was there, and as we can see, it has the same value in both cases. So it works as expected. Notice that the editor doesn't recognize it. It doesn't have capabilities to see that, okay, that's defined as suite scope. One good way to avoid this error here would be to specify the default value for this suite level variable in the variable sections. And that's actually a pretty good idea in general. I mean, with variables that are available, that are created dynamically, to have them initialized like that. It's not mandatory, as you can see that because the test case passes, and I think I'm not going to do that here either. Instead of doing that, let's go to see another new syntax feature in Robot Framework 7.0. This time, we don't get the new kind of marker here like with this var. Instead, we have a new syntax that can be used with tags that tests or keywords get. Let's first of all add some common tags for all these test cases, and that we do here in the settings section. We use the test tag setting, and we can use something like common tags. So now all these test cases, well, we have only two. They got both of these tags, common and tags. Let's create another test cases where we don't want to have that particle, for example, that common tag. And we can use this using that kind of a minus tag syntax. So now this test case, it can have its own tags, and in those tags, we can use minus common. And now this test is not going to get that common tag, but we can also give it some of its own tag. So now it is going to get tag own, but not tag common. Test case is empty while it has tags, but it doesn't have an implementation, so it has an error. So let's add something. Basically, no operation is good for these kind of cases. Let's see how that works. We can see that it succeeded. Well, that's not a big surprise, but let's go to the report. It's easier to see there how it works. If you look at all the test cases, we can see that the minus tags in the test case got tags on and tags, and all the others got this common and tags. With earlier Robot Framework versions, you get the same effect with the default tag setting, but that setting is nowadays considered deprecated. There's no visible deprecation warning yet, but there will be in the future, and eventually, sometime in the future, that whole setting will be removed. So this minus tag syntaxes should be used instead. There's also another change related to tags, and that's related to how test cases are selected from the command line. Now, if I select test cases, so that I use include to select all test cases with tag own, and I also use test option to select test cases with name, so that I want to run test case with name var syntax. You see that the two test cases are run. So all test cases that have the tag own, and also all test cases that happen to have name var syntax. In earlier Robot Framework versions, this worked differently, because then test cases to be run needed to have both this matching tag and also needed to have a matching name. But nowadays, these settings are cumulative. There are also other changes to the behavior in Robot Framework 7.0. Let's go through some of the deprecations. Probably the most visible deprecation in this release is the deprecation of the return setting. So, return setting deprecation. Let's create a test with that name. And we now need to have a keyword that actually returns something. So let's do that. Return something. So that's the name of the keyword that we need to create. And let's do that. Return something. So the old way to return something from a keyword was to use this return setting. And it just gets the value that we want to return. So I literally return something from that keyword. So this was the old way. It still works, but nowadays it's deprecated. This syntax has a problem that it's only used at the end of a keyword. So there's no possibility to use this conditional somehow. And that's why already in Robot Framework 5.0, we introduced a return statement that is much more versatile and should be used instead. It should have been used already in earlier releases instead of the return setting, but now the return setting is deprecated, as we'll see shortly. It still works, so let's validate that it works by using should be equal to validate that the value that we get is something. So let's see how it goes. Oh, by the way, the editor is also telling us that it's deprecated, so it says that the return statement should be used instead. I think we'll see the exact same warning here as well. So now we see that check succeeded, so the syntax worked, there was no failure, but we got the warning that the return is deprecated and return statement should be used instead. Another case where you can actually get similar kind of a deprecation warning nowadays is the singular headers. So instead of using this kind of plural headers with s at the end, we can still use singular headers like this, so keyword, but that is also deprecated. So now we can get the two deprecation warnings. Singular section headers like keyword are deprecated. The reason for this deprecation is that when we added in Robot Framework 6 localization, we decided with all languages to support only the plural format, and now also with English, we decided to deprecate the singular format. These deprecations, especially the return setting deprecation, can cause a lot of deprecation warnings in old Robot Framework projects, and updating all those cases manually can be a bit annoying. The good news is that the excellent RobotTidy tool can do that automatically. I have RobotTidy installed, so what I can do is that I use this RobotTidy and then path that file, and it will update this in place. As you can see, one file reformatted, and the return setting was changed. Return statement and also the header was changed. Tidy does also other kind of a transformation here. What it actually did was that it added two empty lines here instead of one, which I'm fine with. But otherwise, I think it looks exactly like earlier. If you are not happy with some of the changes that Tidy does, then you need to configure it to not do such changes and only do, for example, return setting changes and so on. Anyway, that is definitely an easy way to get your data updated to new standards. So, in addition to these deprecated features, there's also one pretty big backwards incompatible change. That change is really related to the output XML file that we get as part of the execution. So log and report are files that everybody probably is familiar with, but the output XML file is something that not most people don't typically look too often. It contains all the information about the execution in machine-readable XML format, and it's used by various tools, such as the Jenkins plugin to show statistics about execution. The backwards incompatible change in Robot Framework 7 is that we changed the output XML format slightly. Most importantly, start times and end times are whenever keywords and tests and so on start and end, they are shown differently and earlier. This means that tools using output XML file may not be compatible with it. Good news is that Robot Framework Jenkins plugin has already been updated, so it should work without changes out of the box. But with others, if you encounter problems, what you can do is that you can use the new option legacy output, and everything works exactly as earlier, but now this output XML file format is the same as in earlier versions. There's also another change related to output files. This time it's a new feature, not a backwards incompatible change or something like that. The feature is that we can get output files also in JSON. That is not yet supported as part of execution. It will be supported in the future, but a robot tool that you can use normally for generating logs and reports based on existing output files like this one, like this, so it can generate log and report for us. It can also generate new output files if you want, and it supports JSON, so that I can use output option and tell that, okay, I want output file in JSON, so that I just use the JSON extension, and now I got the JSON file. So we can see that it looks something like this. Not very interesting, possibly. But yeah, that can ease integrating robot framework to syntax that natively supports JSON. And in the future, it will support it directly part of execution as well. In addition to using robot to generate these JSON files, it's also various kind of programmatic APIs to convert robot framework result to JSON and back. But well, that's, I guess, the most important enhancements and other changes that non-robot framework users creating tests or tasks should be aware of. And next we then go to enhancements for the extensions API. Okay, then let's look at what's new in the library API. I have here already created an empty library file and already taken the library into use. So let's see what are the new enhancements that we can use. The biggest enhancement related to library API is the possibility to use mixed arguments. So the possibility to create a keyword in a library that accepts both embedded arguments and normal arguments. So let's see how that works in practice. Let's first create some examples here. I need a test case name. I guess this is describing enough, and then some example keyword. So let's use something like this. Number horses should be 1. And then, so this, I want to have a keyword like this. But I want this horses to be embedded argument, so something that we can change. And then this is kind of a normal positional argument here. So I want this to be impossible. Number of dogs should be. So I should be able to say something like that. I also want it to be possible that, assuming that this second argument is named count, I could use count is, I don't know, 7. So that I can use the named arguments index. So I want all these usages to be valid. Also, I should be able to use something like cats or whatever there instead of horses. But yeah, let's see how this works out. Before we go and look at the library, so to point out that this syntax was added for user keywords already in earlier robot framework version. So that works with user keywords already now, but well, worked already earlier, but now also with robot framework 7. Also, library keywords support this syntax. How do I do that? Well, we need to have a keyword here, something like a number of animals should be. This function name doesn't really matter too much. We'll see soon why. but well, it needs to take 2 arguments because I have two arguments. One is the embedded one, and the one is the positional one. The first one is animals, yes, and the second one is count. Let's just print those so that we can validate in the log file that we got what we expect. So now we have the basic implementation here, but the name is still wrong. So we need to give this keyword a custom name, which is we always kind of need to do when creating keywords with embedded arguments. And the easiest way to give the custom name is using the keyword decorator that we can import like this. So we put keyword decorator, and then we use the keyword decorator to give a custom name. Number. I cannot write. Number of animals should be. The key thing here is that these animals that we want it to be, this part that we want to be an embedded argument, we use a robot framework variable syntax there. And we can see that we have one embedded argument there, but our keyword actually accepts 2 arguments in Python. And now it works so that the first argument here will be passed in as the embedded argument. So this robot framework will see that in a keyword name, and the second is then used as a normal argument. With earlier robot framework versions, this is actually an error with those the number of embedded arguments and must match the number of arguments this function accepts. But now there can be leftover arguments. They just need to be specified here in the data as positional or named arguments. So that should now work. Let's see what happens. It does work, so that's fine. The editor most likely hasn't yet noticed it. The library hasn't been updated or something like that, but as we can see, robot framework is fine. It passes. Let's still see from the log file what we actually got. And we basically see that we got horses 1, horses 7, and dogs 4, so it worked as we expected. That's convenient. Another convenient feature related to library API in Robot Framework 7 is related to argument conversion. What is now supported is so-called literal conversion. So let me demonstrate that with another example. So let's assume we want to have keyword turn that we can use with argument left. So we want to turn left. We also want to be able to use the same keyword with argument right and regardless case. So both lowercase and uppercase should work, but we don't want it to work with, for example, around. So we only want to support left and right. So let's see how to do this. If I now add here keyword turn, and notice I don't need to use the keyword decorator here because there's no need for a custom name. It accepts one argument direction. And if we do it like that, we can, for example, print the direction so that we can see that also from the log file. If we do it like this, it passes. Of course, there's no validation. We just accept one argument. That's it. But if we import literal, which is a new thing in Python 3.8, which is also the minimum version Robot Framework 7.0 supports, so you can use it without worries. So from typing, we import literal, and now we tell to Python basically, and also then the Robot Framework that this value can have literal value left or right. And now when I execute this test case fails because argument direction got value around that cannot be converted to left or right. So the error message is pretty explicit. And in the log file, we can see the same thing. And we can also see that when we used left, we got that. And when we used right with capital letters, we actually got right with lowercase letters. So this wasn't exactly what there was specified in literal, but we were able to convert it because it matched that. So that's fine. The keyword will anyway always get one of the values explicitly specified there with the literal construct. The array didn't match anything, so it failed. Earlier robot framework versions, already a long time ago actually, support enumeration conversion, which basically gives you the same effect. The enum conversion is kind of more powerful because you can give a documentation and so on, but it's also a bit more boilerplate. So this literal conversion is really convenient. There's no need to create a separate enumeration classes or anything like that. You just use this. Obviously, if you needed to use this direction literal multiple times, the overhead of creating the enumeration class is quite small, and that probably would be a better idea. But in simple cases, this is very convenient. Another argument conversion related enhancement in Robot Framework 7 is that we can use, if we want our keyword to accept, for example, a union, so that the argument can be of multiple types. For example, this count, nowadays it's accepted without conversion. It's actually going to be a string when passed in here. But we can tell that, okay, we want it to be an integer or float like this. So that's a union syntax. So we want it to be then those would be accepted. Well, I don't know, number of horses should be 2.5 or something. Doesn't possibly makes much sense, but anyway, this is just an example. As we can see, it succeeded because the numbers are always integers. This syntax requires Python 3.10. I'm running on with Python 12, 3.12, so that's fine. I don't have any problems. But if I was running with 3.8, this would be a syntax error. New robot framework versions allow then using this syntax, so basically making it a string. So this is kind of a Python syntax that Python type checkers use when working with older Python versions, and nowadays robot framework also understands it. So this would also work with Python 3.8. That's pretty nice. I can also now, I could leave it without the quotes because it runs there, but I guess I can leave it like that. Another enhancement, which is typing related, not type conversion related, because there's actually no type conversion, is that if my argument has a default return value like this, that will be shown in libproc outputs. So if I would generate documentation out of this with libproc, then it would show that, okay, the return type is string. Can be convenient in some cases. But yeah, I guess those are the most important enhancements related to the library API. Next, we are going to see how listener interface has been enhanced. Okay, in this last part of the presentation, we will cover the enhancements to the listener API. Listener API exists there to get notification about various events during execution, such as test cases or keyword starting and ending, and it also allows making modifications to the data dynamically during execution. If you are new to the Listener API and want to learn more about it, you can check the user guide or watch the RoboCon 2023 presentation about that topic. In this presentation, we are not going to cover Listener basics. Instead, we are going to see all the new interesting enhancements to the Listener interface. I have already created here an empty listener file, so there's just a Python file, no code yet, and I have the old test cases. Now I can run those tests with the listener. Of course, the listener doesn't do anything yet, but I can run it like this. I run command line, and then I do the path to listener file, and then then tests. Notice that I've changed the terminal from terminal position so that I have more room for code in the editor. Anyhow, I can run these tests, put that, and there's no changes. But this is actually already an enhancement, because with earlier robot framework versions, there would have been an error about this listener not specifying the API version. But now in robot framework 7, there's a listener version 3 is a default, and then I don't need to specify the version explicitly anymore. Listener version 3 was introduced already in robot framework 3.0 in 2015, and it allows making modification to tests and suites during execution. It does not, however, allow making modification to keywords simply because it doesn't have hook methods for start and end keyword. But well, nowadays it does. So the absolutely biggest enhancement in Robot Framework 7.0 is the addition of start keyword and end keyword method to the listener API version 3. This start keyword, for example, is called with 2 arguments. First, it is typically called data, and the second one is result. So, like that. I can print some information about those. For example, data has name, so on, and we can see how it works. So now, as we can see, there's some names there. It's kind of messed up, so I'll use quiet mode here in console, meaning that there's no information about whatsoever about those test cases that started or ended there. So it's only the listener logging that we see. So yeah, we got those keyword names here. This object have various attributes. If you look at the API docs, you can find them, but the possibly better idea is to use types hints. So we can import robots running module and result module, because these modules contain these various model objects that are used, and we can use them easily as type hints. And that way editor will give us completion. So this data argument is actually running module from the running model, a keyword object from there, and this result is from the result model keyword object. So they have this running model keyword and result model keyword have a common base class. They have a lot of similar attributes, but there are differences, like result having a status and start times and so on. So we can bring data's name. Now that we have that, type hint there, we can our editor can target the sources, for example, line number, and then result has, for example, status. So let's run this now. And we can see that, okay, we have log many. It was used on line 18. So that's where it's used in the data. You can see that here, log many used on line 18, log in 22 there, log again in 25, and so on. This also, we can see the library keywords, but we can also see the return something that is our only user keyword here. It was used on there on line 32, and that matches here. In all cases, the status is not set. Well, we haven't keyword execution is just it started, so that's it. The only other way, basically, only other status it could be that it could be not run if we already at that point knew that keyword it won't actually be executed at all. If we implemented end keyword, then of course the status could be pass, fail, or skip as well. So if we implement only the start keyword or end keyword, so what we get are object representing the data here. So exactly here, like the name that used here and possible arguments. So we can of course also log those arguments. So let's see args. So there's a bit more information here. So now we can see all the arguments. And then we get the result object there. But we don't know at this point, well, we actually know, but we don't know if we implement only this keyword, we don't get access to the actual keyword implementation object, so for the possible user keyword or library keyword. But we can get that access as well. So if instead of implementing this get generic start keyword, we implement start user keyword, then this hook method is called instead of start keyword with all user keywords, and we get an access to the implementation object as well. The signature of this hook method is then data, so that this is the same as with the other one, like with the start keywords like that. Then the second one is often called implementation. I think I'll make it short, like impl in this case now. And that's also from the running model. What this type is, it's a used keyword object. And then finally the result was given here as well. And that's exactly the same as with start keyword. If I don't do anything, there's a small change to the output here. This change is that there's no information about this return something anymore, because now with user keywords, this start keyword method isn't called at all. This is called instead, and it does at the moment nothing, but let's do something. So now I'll add some more printing here. Maybe I'll use a bit nice formatting, something like user keyword used on. So this is the same information as earlier. That was the name of the keyword, and that's where it's used. We can now also use we can also then add more information here. Because this implementation object has also a line number, but that's the line number where it's actually been implemented. Oh, what's like this? I guess there shouldn't be a syntax error, so let's see. So now we got used on line. Maybe I want to make this kind of proper sentence. But anyway, user keyword return something used on line 32 and implemented on line 2. Of course, we can also log where, because that's in the implementation object non-argumentable source. So user keyword return something used on line 32 and implemented on line at. This user keyword is implemented in the same file, so it's the same tests.robot as earlier. This is a path object. Path instance, so it actually, if you don't want to show the whole name, we can just, whole path, we can just use for a small name and it's a bit shorter. So yeah, this way we get much more interesting information, so we can see where it's implemented, which file, which line, and so on. But what is very interesting is that what we can also do is that we can actually modify the keyword. So this implementation there has body, and we can modify it. So this body, basically, first of all, we can print what it contains if we want to. What's there. It's return something. Well, that's a string representation of that. So let me change this implementation so that you can see what that is. And we can see that it's a return object, because that keyword had that return statement there. We can change it. So instead of printing it, let's change it. So we'll first we could, for example, we could clear the body. So now there's nothing anymore. And then we could add a keyword there. Like, for example, you need to create a keyword there. Let's have a log and then arguments to that keyword. Hello, RoboCon. So this is the name of the keyword and these are arguments. That's a list. I could give, for example, a second argument. Well, I could give a invoice log level, for example. So now it should work. And if we go to the log file now, we can see that this return something keyword has failed. Oh, well, this return setting deprecated now fails because it doesn't anymore return anything. This returns something. Instead, we can see that it has the body test on this new keyword that I added there dynamically. So I made a modification to that keyword. Obviously, I can add the return back there if I want. So I can use this. I can say, okay, create return there, and then it accepts just the values, and the value was, I guess, something. So now it should again succeed. Instead of clearing the body and then adding the return back, I could have, of course, modified, preserved the original and just add this keyword there in the beginning as well. But yeah, stuff like this is possible. This can get even more interesting because via this implementation, I have access to the let's just print it out. I have access to owner, which is the actual resource file object, and the owner has keywords. And I could actually manipulate those keywords. I could add even new keywords. So if there's no keyword not existing, I would go there and add a new keyword there, which is kind of interesting. I'm not going to create that kind of examples here, but there are examples that the repository that where these examples is going to be further examples are linked from there, and there are even crazier examples that I have here. So yeah, we can do interesting thing. We can make modifications to user keywords and even create new keywords if we want to. Well, we can also get more information about library keywords. So here we had this start user keyword, so we can also implement start library keyword. And the same thing as there, it gets 3 arguments. The data is again this running keyword. There's no changes to that. It also gets implementation, which this time is from the running module again, but it's a library keyword object, and then the final argument is yet again result, which is the keyword from the result model. So same signature otherwise, but the implementation that we are going to get is a different kind of object. But again, if we use just pass and now we do that, we can see that there's only that one print now because all library keywords are called here, and this isn't actually called at all anymore because there's user keywords and library keywords only, and there's nothing that will no keyword that will get called here. There's actually third kind of keywords that could occur there, and then in those cases this hook method would be called. The third kind is kind of errors. If you have like a syntax errors or something like that, then in those cases that's invalid keyword. So it's not a library keyword or user keyword. It's invalid, and then in those cases now this start keyword hook method would be called. Alternatively, you could add a start invalid keyword method, and in those cases this would never ever be called. I'm not going to have examples about those invalid keywords. I hope you don't have such data. And so, but further examples that I already mentioned have examples related to those as well. But let's get back to the library keywords. I'll copy that print there because it's kind of we can kind of reuse it. Obviously this isn't anymore user keyword, so I'll change that to library keyword. but I guess this otherwise will work because the data is same, so that will work. And also this implementation object there has line number, and there's also the name for the source where it comes from. So let's see. So now we can see that library keyword log many was used on line 18 and implemented on line 3092 at built-in py. So this is from built-in library. That's where it's implemented on that line. Log is implemented there and so on. So we get access to those built-in keywords as well. And then there's this our keywords in our new library that we created, the custom library. So we can there see that, okay, turn was implemented on line 11. And this number of horses should be on line 7. What's pretty interesting here is that with these library keywords, our implementation has owner, exactly like the user keyword had. And that owner is, this is a robot framework object representing the library, and it has instance. And this is the actual library instance that we have. So we can log that as well. And you can see that we got the, here we got the robot built-in object there, and then we got this module here. So we can get actual access to the library that is currently used. And if the library has some kind of state, we can inspect that state, and we can also modify it. So we have a direct access there to make even more kind of interesting changes and inspections. So this new start and end keyword, the methods that have now been added are very, very powerful. You get much more information that you get with listener version 2, and also the possibility to make modifications, of course, totally new. With listener version 2, it has start keyword and end keyword, and those methods are called also with control structures such as if structures and returns and so on. With the listener API 3, that is not the case. If we are interested in those control structures, we need to implement separate methods for those. So, for example, we have some the return statement there. If I want, I can implement start return, and then that this method is called whenever the return statement is used in a test. Well, actually in a keyword. So it has the same signature as all this start keyword they had. So well, same signature, meaning that it gets 2 arguments data, and that is now from the running model. It's a return object, and then result again from the is result model and also return object. And now, if we want that data has values, these are the values that are returned. And if I want, I can change this to new, so that instead, and what will happen now is that it will again break our test, because this was expecting to get something, but now our listener changes this return statement. Well, in the log file we still see something, but what the value that was actually returned was new. The reason, by the way, we see something is that we didn't change the result object. I would assume that if I would change result values to new, then also that would be updated. So now it's that. This is actually going to be more useful than actually modifying the value that is returned. That can be a bit surprising, but this value modifying the result here can be useful, because then you can, for example, hide some sensitive information. So let's make it a secret. And now that's all things shown. Maybe I do this. I don't even modify the values. I just change that. So now the test should still pass. It succeeds, yes. And now the value here is secret. Well, the value is shown still here, so we need to do some more modifications to get it totally hidden. But anyway, this is a kind of a start. So yeah, that's actually a good example also, that instead of, well, in addition to modifying data so that things happen differently, we can also modify results and, for example, hide information here. Well, I believe that's about it. Actually, there's one more thing. If you want to get notification about each and every possible event that there occurs, so all control structures and so on, you can implement a method called start body item, and it also gets to argument the data and result. And I can just print, for example, that. And now if I do this, I think there's nothing printed out. There's actually, yeah. So there's var syntax. I didn't have any hook method for the var, but now that this method matches there. So if I wanted to specially handle this var statements, I could implement start var or end var. But now when I don't have those, this start body item is called instead. So that it's not called with return, because return has its own hook method. This is the until last result. So if you want to have a single method that gets all notifications, just implement start body item, and that's kind of similar than start keyword in listener version 2. Then you just need to handle these items differently, because you're getting different kind of objects here, not always, for example, like here, it's always return object, so you know which attributes it has. But yeah, I guess that's enough. It's already getting pretty complicated, but if this isn't enough, you can find further information from the repository that contains these examples. I hope this has been useful presentation, and I'm really looking forward for new tools and plugins and so on that use the new listener API, possible the new enhancements to the library API and so on. And I also obviously hope that the enhancement to data syntax are useful. Thanks for watching, and if you have questions, I'm happy to answer them in the Q&A.